Hello everyone. Today we are going to solve LeetCode problem of the day, sliding window maximum. So let's first read the question. So here we are given an array nums of integers, and also we are all given a value k. So what we need to find is the maximum of a particular window. So as you can see here, the window size is 3. So we first need to find the maximum in this window. Then this window will move to the next place. So now our window will have these three elements. Then and the maximum of these are 3. Then our window will move to this next, and the maximum in this window is obviously 5. Then similarly it will go on till the last window. So how can we code it? So the first approach is quite simple. We can simply take the window of size k, and we can iteratively find the maximum in this window. So our time complexity for this will be, so for naive approach, what will be our time complexity? So our time complexity will be, as we have to traverse this whole array, so this will be big of n. Big of n. Then for every window we need to process k items to find the maximum. So this will multiply big of k. So our time complexity will be big of n into k. So this was the naive approach where we find a window and get the maximum of this window. And as you can see, the time complexity will not be sufficient to solve this problem, as we are given 10 to the power 5 and 10 to the power 4. So we need to perform a total of 10 to the power 9 operations. But it's not possible because we can perform at most 10 to the power 8 operations in 1 second. So the solution will not work. So let's move to the efficient approach. What we can do is we can make a queue. Sorry, we can make a priority queue. Not priority queue. We can make a deque. So what we want is to keep the maximum of any window to the front of our queue. For example, here we have elements 1, 3, -1, -3, 5, 3, 6, and 7. So what we want is to keep the maximum. So our first window is this. We want to keep the maximum of this to the front. And now what we'll do, as the window will move forward, so we also need to check one condition, that if the front element is not out of the size of this window. So in our queue, we will use two things. We'll make a pair of queues which will include index, and which will contain index and the element which we have. So when we are trying to enter a new element, we will see if this new element, so suppose first we have 1, so 1 will come, and there are no more elements to process, so we'll move forward, we'll move to go to 3. So as we can see, once we encounter 3, there is no use of 1 because it's smaller than 1. So we can have one condition where if or while you can say, while the back deque dot back dot, we can use either first or second place to keep the number and other to keep the index. So I'm using first here to keep the number. So while this is less than, here we have given nums, so we take nums at r. So while this condition is true, we will be popping out the elements from the back. So deque dot pop back, and so when this 3 comes, this 1 will go out of the queue, and we also need to check if the new element is, if the element at front is not out of the range. So we'll also do, but we need to do that first. So we will first check if the, first we'll check if the deque is not empty, not deque not empty. Same condition we need to check here also, because we are trying to get hold of the deque dot back, but if the deque is already empty, we'll get an error. So we also need to check this condition over here. So if deque is not empty, and if deque is not empty and this first element of the queue, the front of the queue, the index of the front of the queue is going out of the range of this window, you can suppose. So I'm writing it over here, not a space mark there. So if deque dot front dot second is less than, so how can we check the condition? We have deque dot the index of that position, plus we need k minus 1 elements more. This can be inside the window. If it is less than I, then we need to pop deque dot pop front, this front element. So now we have condition checks, and now we'll add this element deque dot push front num set I and I, the index, and that our queue will now contain all the maximum elements. So let's first code this part. So let's see, what we need is an answer vector. Okay, we can say res. So this vector will contain our result. We also need a deque and pair of deques. So I'm making pair of deques, and now we'll start traversing the elements. So for int I 0, I is less than dot size. Okay. Now we'll see if not deque dot empty. So if deque is not empty, and wait, and we need to get hold of the index. So we'll do deque dot front, so front element, and then we will go to this index which is stored in the second place. So deque dot front dot second and k minus 1. So this will give the range where this, so this will give the index where till where this element will be valid. So if this index is less than our current I index I, so we need to pop this element. So we will deque dot pop front. now, all the elements in our window is are inside the range of k. So now we have to check if the new element while is less than if the new element is greater than the elements at the back of the queue. So if not, deque dot empty. So if deque not empty and the element deque dot back dot first is less than the current element, which is num set I. While this is true, we need to take out the element from the back, deque dot of back. So what this will ensure is the elements that are less than the current element will be taken out of the queue, because these elements can no longer be the maximum of their or the upcoming windows. So we don't have any use for them. Now what, as we have taken out we've checked the range, all the elements present in the queue are inside the range and taken out the smaller elements. What we need to do is just push we are pushing from the back. So pt dot push back the element which is num set I and its index. Now we need to insert the answer element in the answer, but when we need to start, because we are starting from the zero here. So when if our I so when our I will become greater than or equal to k minus 1, because this is the first index where our window size will be of k elements. As you can see here, 0, 1, 2, and we k size is 3. So at the second index, we start forming the complete window. So that will be k minus 1, 3 minus 1, 2, second index. So from there we get this. What we need to do is we need to add this, as we have made sure that the front of the queue will be maximum. So just we simply need to insert press dot push back. We need to push the front of the deque dot front nums dot of front deque dot front, and we have element in the first place deque dot front dot first. Sorry, this will be deque here. So we simply need to return this. Let's check it. So it got accepted. So it's getting accepted quite right. So thank you. See you in the next video.